Hello, it's homework time again. We need to spend a little bit of time thinking about the things which we covered in that difficult lesson today on the cathode ray oscilloscope. What I'd like you first to do is to go to this address here. I'm going to put this address into the comments section of the YouTube video. Just read through what's on there. It's from GCSE Bite Size. It will remind you of the necessary knowledge which you need to have acquired from the lesson. I've then got a small series of questions which I need you to complete in your book. I'm going to give you some help with these questions now. So, first off, let's take a look at question 1. A cathode ray oscilloscope with nothing attached to it has a 2-volt cell attached to it, and the dot on the oscilloscope jumps up 2 squares. You'll be able to use this information to think and work out how many volts each square up represents. When other batteries are connected to the same cathode ray oscilloscope, we get 2 different sorts of spot. What you're going to be able to work out for me in parts A and part B of the questions in this worksheet is the voltage of the battery attached here and the voltage of the battery attached here. You'll be able to do that having worked out how many volts each square up represents from the first part of this question up here. Remember, you can get positive and you can get negative voltages. It depends which way round you attach the cell to the cathode ray oscilloscope. Answer those questions in your books now. I recommend pausing the video while doing so. So question 2 is slightly more tricky, but it still won't take you very long. So when a 2-volt 50Hz alternating voltage was applied across the Y plates of an oscilloscope, don't worry about the Y plates bit, the display showed this. You'll be able to work out using this information here and the trace here, how many volts each square up represents, and how many milliseconds each square across represents. Remember, if a wave has a frequency of 50 Hz, it has a time period of 1 over 50 Hz. You might like to work out what that is. The time period is the length of time taken for one oscillation to occur. Using that information, you'll be able to work out how much time each square across represents. That information is important. It will let you answer questions C, D, and E. So when different signals are applied to the same machine, the traces are obtained. Describe the traces in the applied signals in as much detail as you can. What I recommend you do for me is describe to me the voltage of the signal, the frequency and period of the signal, and also say a little bit about its shape. That's all you need to do. So question 3 I think is self-explanatory, going on what you've known from year 8. If you need any help, you know where I am, you know where my room is. Spend no longer than 30 minutes on this homework as ever.